block diagram now on your screen covers our current PIC24F products. At the time of this recording, the family consists of 9 devices covering memory ranges of 64K, 96K, and 128K bytes, and 64, 80, and 100 pin packages. By the time many of you listen to this web seminar, there are likely to be significantly more parts. From the point of view of the material in this seminar, there will be very little change, as our devices tend to be designed with peripheral set compatibility in mind. On the right side of the screen are the peripherals of the PIC24F. Today we will cover the peripherals in green and blue, beginning with the A to D converter, shown in blue. Microchip utilizes a couple of A to Ds in various 16-bit microcontrollers and digital signal controllers. Today we will cover the 10-bit 500K sample per second ADC being used in the PIC24F family. The PIC24F 10-bit ADC was selected for the PIC24F to provide a high-performance ADC that supports a cost-effective solution. Before we take a look at the ADC, please note the red VDI symbol in the corner. This symbol will be used to indicate that the peripheral we are discussing can be configured using Visual Device Initializer, or VDI. VDI is found under the Tools menu in MPLAB IDE as Visual Initializer. VDI allows a programmer to easily generate initialization code for a peripheral. Now on to the ADC. The ADC on the PIC24F is a 10-bit successive approximation ADC designed to provide high-speed conversions on a cost-effective microcontroller. Some of the features of the ADC are a 500K sample per second conversion speed, up to 16 analog channels. The A to D converter can be referenced to external voltage reference pins or analog VDD or analog VSS. The ADC includes automatic channel scan mode. There are selectable conversion trigger sources. There's a 16-word conversion result buffer with selectable buffer fill modes and 4 result format options. The A to D converter can also work during CPU sleep and idle modes, generating an interrupt after the conversions are complete. As mentioned earlier, the A to D peripheral on the PIC24F is a single sample and hold 10-bit ADC with 500K sample per second conversion rate. Up to 16 analog input pins can be multiplexed into the sample and hold circuit. On lower pin count devices, not all 16 of the inputs will be implemented. The ADC module contains a 16 result buffer. The 16 result buffer can be very useful if you'd like to make a number of measurements in sleep and then to wake up to act on the measurements. The buffer can also be split into 2 8-result buffers. Splitting the buffer into 2 provides time for the controller to access half of the result buffers, while the other half are being written by the peripheral. Data conversion results can be stored in 4 different formats: unsigned integer, signed integer, unsigned fractional, or signed fractional. This allows the programmer to have the A to D results stored in the format assigned to the variables being used. The reference voltage can be assigned to any combination of external references and to the analog supplies. The A to D allows the user to establish a predefined scan pattern. Finally, the conversions can be triggered by a timer compare, a PWM, or an external interrupt. In summary, the PIC24F's 10-bit ADC is designed to be fast, flexible, and friendly to low-power environments.